Okay, so just waiting for the presentation to. Okay, so I know that I am the only one between you and the lunch. So I will try to make it quick. So this topic is about FSAF ANSYS workbench solution applied to powertrain components, and this work has been done by me, Ashwani Goel, as well as with Tom Price and Giovanni De Moraes, where both of them are in research and development group. So if we look at the fatigue analysis process, then the analyst will do the finite element analysis, and the output of that finite element analysis will be one of the input to FSAF. And the second input will be loading data, where you will not be considering the most severe loading, but whole of the loading which will come from the experiments, and finally the material data. So these will be the three inputs which is needed in FSAF. Then FSAF will use its biaxial strain life algorithm by default, and it will calculate the fatigue life. So as you can see in this process, whatever finite element analysis you use, if you are using ANSYS for this particular process, first of all you have to solve your ANSYS model, then you have to use whatever output you are taking from the ANSYS model into FSAF. You need to open your FSAF GUI, and then it will write the model in RST file, which you can again open using ANSYS Mechanical. So there are a lot of manual labor which is involved in this workflow. And if we look at the FSAF, what are the different processes which we use in order to set up the analysis? The first is we pre-scan the finite element model. We decide like what is the steps and increments we want to use in order to do the fatigue analysis. We also manage the groups in which we can choose which of the group in the fatigue analysis we want to use to do a fatigue analysis. Also, we can then use those groups to define the surface finish factor, material, as well as algorithm. We can use any of our material in the material database if you like. And we can also define the loading. And finally, if we have a target life in mind, we can define that factor of that target life, so that FSAF can determine the factor of strength, and also we can define the exports. So all these are the things which we are doing inside FSAF GUI. So the main objective of this FSAF ANSYS workbench extension is to design to allow these simple workflows to be set up and executed without starting any FSAF GUI session. So that is the main objective. But right now it is only possible to do a simple workflow. But if there is a complicated workflow, then directly from ANSYS Mechanical you can open FSAF GUI using advanced setup. So the FSAF analysis groups, which includes like a geometry selections as well as the named selection. So these selections along with the automatic material assignment, this provide the way for the users to streamline the fatigue analysis process using ANSYS. Okay, so this is how the typical workbench feature will look like. In this, we are having a static structural analysis, which is one workbench system C, and there are two FSAF workbench system D and E. So both system D and E are independent of one another, but they depend upon the workbench system C. So if you will want to solve the workbench system D or E, then you have to first of all solve the workbench system C, and then only you will be able to solve a workbench system D and E. Also, in the FSAF workbench, there are different options, and one of the option is this analysis settings. And in this analysis settings, you can choose like whether you want to read strains, forces into FSAF or not. So directly from ANSYS workbench, you will be able to do that. You can also choose the material. So there are two ways to choose the material from the ANSYS workbench. One of them is using match with engineering data. And what this match with engineering data option will do, it will take the name of the material which you have assigned it in ANSYS. And if you have your FESAFE database which has the same name as your ANSYS material name, then FESAFE will automatically assign the fatigue properties to it. But in order to do that, you have to define the location of that DBase file which you have to provide. Otherwise, if you want, you can also use define with FESAFE advanced setup, and in that case you will open the FESAFE GUI and then you will be able to set up your material. The another is the groups which you want to analyze. There are three different ways by which you can analyze the groups. One way is using the geometry selection, in which from ANSYS viewer you can go and select which of the components you want to analyze. Also, there is a name selection, which is like you can create a several name selection and then you can choose over here which of the name selection you want to analyze in FESAFE. And finally, you can also choose all name selection, in which all the name selection which you have defined in ANSYS, they will be chosen so that you can use that in FESAFE. Currently, we just support the dataset sequence. So there is just this option in which you can define which of the steps you want to use for the dataset sequence, and also which of the increment you want to use. On top of it, you can define the scale and repeat on the loading block. So we just support one loading block. We do not support multiple loading block automatically. But definitely, if you want to create an advanced loading, then you can open FESAFE GUI from ANSYS Mechanical. You can define a surface finish value from ANSYS Workbench, as well as you can define the factor of strength from ANSYS Workbench. But if you want to do a more advanced setup, then you can go to this project setup, right click on your mouse and look for this advanced setup button, and if you will click on it, then it will open FESAFE GUI where you can create more advanced workflows. And you can also see the results then in ANSYS Workbench viewer. So what we are trying to do, we are using this FESAFE Workbench component, and we are mainly targeting for this powertrain application. So this is just for the demo, but you can use this for any applications you have, but we have chosen powertrain because it is the most common application which you can see, because the powertrain can be used in converting the power from the engine to the roads. And it has many different components, like it has engine, it has transmission, it has drive shaft, differential, and that's what we know as a final drive. So there are, as we are advancing more and more in the field, there are more and more requirements, as well as we are trying to increase more and more in efficiency. Therefore, there is one particular component in the powertrain, which is power cell, which we want to make more efficient, and so that it can withstand high pressures and temperatures. And what does the power cell composed of, which we have considered in this demo, is piston, pin, connecting rod, and crankshaft. So I have created one demo for demonstrating this FESAFE ANSYS Workbench. So in this demo, we have already created the static structural analysis, and that is there in this model.wbpj. So if we can start the video, please. So what I can do, then I can double click on this model.wbpj, which is having all the static structural analysis results in the ANSYS workbench, and it will open up with this. And it is already having this static structural workbench component, and it has all the green tick mark, which shows like we have already solved this system. But in order to show you that how this works, we can double click on the setup, and once we will double click, the model will open in ANSYS mechanical. And if we zoom in, then we will see that this is the complete model, which has 4 different geometry, which is having a connecting rod, it is having a pin, it is having a piston, as well as it is having a crankshaft. So all these 4 bodies are the deformable bodies we have applied, and we have also defined elastic material properties to all these 4 components in this particular example. And then we can go to the contact. So there are different contacts as there are different geometries, so different contacts has been applied. Most of the contacts are the bonded contact which we have applied, except the contact between the pin and crankshaft. Over there we have applied the frictional contact, but definitely depending upon how you want to use, you can set up your contacts as well as constraints problem. Then in this particular case, we have used 2 steps. Okay, so right now it is meshing, so that is again another process. So we have used a hexahedral meshing on the top of the connecting rod and tetrahedral meshing on the bottom to tell you that we support in FESAFE both hexahedral as well as tetrahedral meshes. And then we are solving this particular analysis in 2 different steps, and in all these steps, first of all, we are applying the acceleration in the acceleration is 0 in the first step, but we are building up the acceleration to 1e7 in the second step, and this acceleration is applying to overall whole of the model. And we are applying the pressure on the piston in the first step, and then that pressure is going down to 0 in the second step. So this is the displacement boundary conditions which we have applied, and that displacement boundary condition is applied on the crankshaft on both sides. So these are the stresses which we got from this particular analysis, and if we want to see the animation, then this is how the animation looks like. So this is how the animation looks like. It is reaching to the maximum combustion pressure, as well as there is some exhaust pressure at the end of the step. So this is what the highest loading cycle we think will have in this particular case, and that's why we have considered just these 2 steps. So once we have set up our static structural analysis, then we have to first of all set up our FESAFE button over here in the model tree. So in order to do that, first of all we will go to Tools, Extensions, and in the extensions we can tell the path of our installation for the workbench. And then we can go to the extension and manage the extension and click on FESAFE. And once we will click on FESAFE, you will see that FESAFE will come on the bottom of the tree, which we can drag on the setup, and the FESAFE will be there, which you can rename that. So right now we have not set up the analysis for the FESAFE, so we can double click on the setup, and once you will double click on the setup, then again the model will be opened in ANSYS mechanical, and over here you will be able to choose your fatigue analysis. So first of all you can go to the project setup, And in the project setup, we want to read just the stresses. We don't want to read strains, force, and temperatures. So the icon size are small, but over here there will be those options, like it will be no for strains, force, and temperature. And then you can also define your material. There are two options by which you can define your material. One is using the engineering data, and if you will use match with engineering data, then you can click on that yellow bar and you can see like which of the DBase you want to use. But in this particular case, we want to choose the material using advanced setup. The second option is you want to choose like which is the group you want to use for doing this fatigue analysis. So I will be using just a connecting rod for doing that. So I have chosen these connecting rod two bodies in order to do the fatigue analysis. And then there is this data set sequence options. I am using both the steps with all the increments. And then once we have defined all these options, then if we want to change further options, then we can go to the advanced setup. And if we go to the advanced setup, then FSAFE GUI will open directly. And as soon as FSAFE graphic user interface opens, it will start reading all the stresses which are there in the ANSYS model. And once it reads those stresses, it will display it in your finite element model setup, where it will read all the increments as well as all the steps, and that's what we have mentioned in the in ANSYS workbench. So once we do that, we can then go to our groups, and in the groups there are two bodies, and those bodies are the bodies which came from ANSYS mechanical, and those you can assign the connecting rod material property to it, which we have used for this particular purpose, as well as you can change the surface finish factor, because in ANSYS workbench right now we can just use a surface finish factor by the value, but if you want to change a more complicated one, then you can definitely do that. You can also define the loading, and in this particular case the loading which we are planning to define is the maximum increment or the last increment of the first step and last increment of the second step, which corresponds to the data set sequence 4 and 8 for this case. So you will be using a data set sequence 4 and 8 as your data set sequence loading for this particular example. Also you can define the factor of strength. Either you can define it over here or you would have defined it in ANSYS mechanical. It should not matter. And once you did it, you can close your FSAFE and you can directly analyze from ANSYS workbench. And once you are analyzing it, it will write all the information in the solution information, and once the analysis finishes, it will tell you the plots. So right now we are just doing this in the real time. So this is stresses which you will be getting, and which you can do a reverse rainbow to see the lowest life is red colored, and it is over there in that region on the crankshaft of the connecting rod. And then you can also plot the factor of strength, and in this case the factor of strength came less than 1, which means that it will not met the design target life. So this example might have demonstrated that how basically you can directly take advantage of ANSYS workbench plugin in order to run simple workflows. But if you are having a complicated workflow, then definitely you can use an advanced setup, go to FSAFE, run, consider your loading of materials which you want to use for your complicated workflow, and then come back to ANSYS workbench and run again. Thank you.
My thanks to all three presenters, Giovanni, Jehuan, and Ashwani. Since we are running a little bit late already, and I would hate to be the one between you and the lunch, may I suggest that you hold off with the questions until the QA session at the end of the day.